All right, here we go. Lesson 10.1, graphing square root functions. So we're going to graph square root functions, and then we may get a little bit of real life problems. We'll see. So when we have a square root function, you can see the graph right here. Kind of looks like a half of a parabola, maybe. A lot of times they're sideways on the graph. We have a function that contains a square root. The independent variable is in the radicand. It's literally under the square root symbol or the radical symbol. We have the parent function, which is the square root of x. The domain of f is x is greater than or equal to 0, and the range is y is greater than or equal to 0. So because we start at 0, 0 right here, and it increases on the entire domain, so the minimum value of f is 0. That's kind of one of the ways that we can see the range. All right, so the value of the radicand in the square root function cannot be negative. The domain of a square root function includes x values for which the radicand is greater than or equal to 0. So we're going to have to solve for this x minus 5 being greater than or equal to 0, and solve for x to determine what the domain of our function is going to be. So for this one, we want to say, okay, we have this negative x. I want it to be greater than or equal to 0. When I divide it by a negative, and I'm working with inequalities, I will reverse the symbol. So that means x can be less than or equal to 0. And that makes sense because right now we have a negative x. So if we try to put in some positive values like 1, 2, 3, or 4, we'd have a negative number under the radical. We don't want that. But if you put in negative values, the opposite of a negative value is a positive value. So that's how we can solve for that one. So go ahead and do number 2 right here. Go ahead and work this out and let me know what you think the domain of the function is. Okay, I'm going to go ahead and work it out. So we'll have x minus 3 to be greater than or equal to 0. So we'll add 3 to both sides. This does not reverse the symbol. So we have x can be greater than or equal to 3. Okay, go ahead and circle that for you. So 3 minus 3 is 0. And then we can be greater than 4, 4, 5, 6. But if it becomes like 2, then we would have that negative underneath there. In number 3, we want 1/3 of x to be greater than or equal to 0. So we'll multiply both sides by 3, and we get x is greater than or equal to 0. So to graph them, we'll describe the range after we're done graphing. So we go ahead and use the domain, right? So we know if we have the square root of x, we want greater than or equal to 0. Pick some values, 4, 5, usually good. Substitute those in, solve for f of x or y, plot the ordered pairs, draw your smooth curve starting at your starting point. And then to describe the range, go to that starting point, and then y would be greater than or equal to 3 in this case. So again, we have 3x greater than or equal to 0. Divide by 3, x will be greater than or equal to 0. So if I make my x, y chart here, and I want it to be greater than or equal to 0, so I could start at 0, do 1, 2, 3, 4, so I have about 5 points. So 3 times 0, and the square root of that would be 0. 3 times 1, so the square root of 3, let's figure that out, is 1.7. 2 times 3 is 6. Take the square root of that, 2.4 for your output value. Make sure that you're getting some of these to work out too. So if our input value is 3, 3 times 3 is 9. Square root of 9 is 3. That's a perfect square. Square root of 12, because we have 4 times 3, is about 3.5. And then we'll make our axis here. Okay, so then we'll graph them. Here's our 0, 0, 1, and 1.7, 2, and 2.4, 3, and 3, 4, and 3.5, and it starts to curve there. And then when you draw this, okay, like this, we'll describe our range. is y is greater than or equal to 0 because it's going to increase greater than there. All right. Number 5. Why don't you go ahead and work out number 5. Let's start by determining our domain. So we have this negative x has to be greater than or equal to 0. So if we're dividing by a negative 1, that means that x has to be less than or equal to 0. So let's pick some values that are less than or equal to 0 and graph number 5. All right, so I got a graph. I have a 0, 0. I have negative 1, 2. I have negative 2, 2.8, almost 3. I have negative 3, 3.5, and negative 4 and 4. So if I were to draw it, okay, and then my y would be greater than or equal to 0 for my range. All right, for number 6. In number 6, we have x plus 3 to be greater than or equal to 0. So we want x greater than or equal to a negative 3. So we make our xy table. We can start with negative 3, negative 2, negative 1, 0, 1. So we would substitute this in. So negative 3 plus 3 is going to be 0. The square root of 0 is 0, and then minus 1. So negative 3, negative 1. Okay? When we have negative 2 plus 3 is a positive 1. Square root of 1 is 1. 1 minus 1 is 0. Negative 1, this gives us the square root of 2. And if I calculate that, that's about 1.4. And then we'll subtract 1, and we get a decimal value of this 0.41 something. Okay, so 0 plus 3, now we're taking the square root of 3, and then we're going to subtract 1, so we'll get about a 0.7. 1 plus 3 is 4, so we should get 1, 1. All right, so I'm going to kind of come over here. All right, so negative 3, negative 1, so 1, 2, 3, negative 1 is right here. Negative 2, 0, negative 1, about right where my messy axis is. It appears that I wrote part of the number. I don't know what I said in the video. I didn't mean to. So we were taking the square root of, so we had 0 plus 3, the square root of 3, and then subtracting 1, so it's 0.7. I might have said 0.7 and 0.1. I don't know, but this makes a little more sense if we're almost at 1, it's a little bit higher. And then we're at 1, 1. So we'll draw our graph kind of like this, right? Now, look at this range, right? It's starting right here at negative 1. So y would be greater than or equal to negative 1. All right,